Hi folks, Chuck Black here. We're doing 52 weeks of Python. We are in week number 42 and we are beginning a series of lessons on the topic of databases. What are we going to talk about with respect to databases? Well, one thing we're going to do is we're going to take that mini quokka thing that we built in the last session or two, and we are going to move the data out of the global memory here and into the place where it should be, which is in a database. Why in a database? Well, we're going to look at reasons why we want to store things in a database. We will be looking at different types of database, SQL versus NoSQL databases. In the process of doing that, we're going to look at the cool ways that Quokka uses databases just at a very high level. We're not going to go deep into the code, but we want to understand a little bit about what it is that it does. So all of this time series data that you see represented in various ways, shape, and form, we will be looking at that. Then we'll look at code, which is a very simple application that I wrote that goes through database creation. It goes through database querying. It talks about defining classes in your database, in your SQL database. We're going to go through and modify data. We're going to look at how we can filter data. We're going to look at how we can do ordering by certain pieces of data. And we'll be looking at the output that this program creates and what it means and all that stuff. So it should be fun. It's a pretty long lesson. I will warn you, it's close to 55 minutes, maybe more than that. So hold on to your hats and let's get started. Okay, so starting our discussion of databases, let's think about where we are currently with this code that we are building and where we would like to go. So this is where we left ourselves. We built a little kind of mini quokka type thing with a Flask server, and we have these external applications running, service monitor, host monitor, and device monitor, that are going out into the network and monitoring and discovering the various entities in the network. They're reporting that information via REST API to our Flask Quokka server, and then at some point in time we have these display applications also running that are pulling information from that data. And what we've done is we've built a REST API on top of Flask, and that is where the connection point is for all of these applications into our Quokka server, or mini Quokka, whatever we want to call it. And currently, as you know, we're storing the data in Python data structures in global memory. Now, I mentioned, and you've seen it in the code, that this is a bad idea. There's a number of reasons why it's a bad idea. All you need to do is look it up and people will scream and yell at you that it's a horrible idea and you shouldn't do that. The main reason being that multiple of these entities could come in and try to set the data, and this is not a thread safe type of a thing. In other words, these requests come in on different threads, and multiple people trying to do stuff to the host's data would cause problems. And so we can't do that. And it's a bad idea anyway. It's not scalable and it's not reliable, etc. So what we want to move towards is something that's a little bit more robust, a little bit more secure in terms of not failing and being reliable, something that will scale if we need to. And so that's why we're looking at databases. And so what our solution would look like if we move to databases is something like this. So you see we've gotten rid of the global data and we're storing it out in this thing. My little picture here is representing that we're storing it inside of some type of a database. Now there are multiple types of databases, each of which have different capabilities, strengths and weaknesses, etc. But this is our goal. This is our database solution. And if we had this, then we would have a completely viable solution. In other words, this thing that we did before is really not suitable for most environments, or certainly not for growing it. But this solution right here, because this is a database and all of our data is secure in this database, and when I say secure, I mean it's not prone to failures and other types of disruption, then we're kind of good to go. So this is where we want to go towards. Now that you know where we're going, where we're intending to go anyway, let's take a look at what databases are and why they're a good idea. So I kind of this morning looked around at arguments for and against databases, as you might imagine, similar to politics or anything else these days. People have various opinions, and you can see various flame wars if you look it up on your own, whether you use a database or not. But here are some of the major reasons why you would be interested in using a database. And here, let me pause right here before we go any further. What we are doing for you personally, as you are watching this, we are turning you from somebody who is a copy and paste of scripts that you find online that do various minor Python things into a legitimate software developer. Every software development job that you're going to see that is of any scope or scale or has reasonable expectations will expect you to have some type of knowledge of dealing with databases. When we talk about people who can do user interfaces and kind of the logic of the program and the database in the back end, we call them full stack programmers. And this is what people are asking for. If you look at job search for software, you'll find people are interested in full stack. We're not at this point going into the user interface, but we certainly want to dip our toes into the pool of databases so you have some general idea. So don't abandon this lesson right now because you say, I'll never use a database. You may or may not ever use a database, but if you're going to call yourself a software developer or even a programmer, you're going to want to have some knowledge of this, and it's not a huge investment. So let's proceed with why you would want to use, why you'd want to learn about databases and why you want to use a database. The first thing is scalability. So if you think back to the data that we had in those dictionaries in memory, clearly at some point in time you're going to outgrow the ability of your application to run when you have a huge number of hosts or devices or services or whatever it might be. Any application has limitations in terms of what it can store, and so doing it in a database gives you a huge amount of scalability. In fact, it's almost unlimited how you can scale the data that you store when you're using a database. And different types of databases have different types of scalability, typically called horizontal scalability versus vertical scalability. You don't have to worry about that, but just know that it scales much better. A second thing is this, performance. Now you may look at this and say, well, wait a minute, the little simple things that we did with our dictionary, that's pretty fast. Your database isn't going to be as fast as that. And yeah, storing it on a disk and doing database queries in our simple, trivial little situation is definitely going to be a little bit slower anyway than just getting something out of a dictionary that's in memory. On the other hand, databases have been worked on for the last 60 years to become performant and to be able to handle queries that ask for all kinds of different things, such as doing stuff that I mentioned down here, filtering, ordering, things of that nature. So databases are built to be extremely fast, and so we should be able to take advantage of that. Reliability is another important thing. If you're saving stuff in your quokka server inside just the global data there, when it goes down, of course, the data goes away. When you are trying to store it just in flat files, that would be just a regular file on the file system. If something happens while things are going awry, in other words, if the system crashes or your program crashes or something, things will be left in a bad state. Databases are built so that they never end up in a bad state, even if they have the system crashes, hardware failures. All of these things will not result in corruption of your database, so your data is very reliable. Concurrency, we alluded to this a little bit when it came to storing data in those dictionaries. We want to be able to handle simultaneous access from multiple consumers and users of our application, and databases are built to be able to handle that. I mentioned about filtering and ordering. Filtering is finding only certain things, searching for certain things, or excluding things. Ordering would be putting things in sequences. As you can imagine, in the last 60 or 50 years, people have been improving and improving and improving this. If you think about stuff like Google search, Google has their own database technology, but obviously they're not storing things in memory or typically in flat files. They have their own type of database that is very, very good at stuff like this, and we want to be able to do that. In our simple example, we only had a host table or a services table or whatever. That's a trivial lookup, but when you need to do complex queries, like think about Google searches or things that you've done on LinkedIn or Facebook or wherever it might be, then you know the need for this is very real. And the last thing, this is just a keyword that if you were to go on to becoming a software developer and you want to be up to date on databases, you'll want to know about this acronym. It basically has to do with things that I've kind of already mentioned. I'll let you look this up, but it stands for atomicity. That means the fact that things don't get corrupted when one person comes in and does one thing and somebody else tries to do something else. Consistency means that the data is always going to be in a consistent state. In other words, it's never in an in-between state. Isolation means that your transactions are able to be isolated such that if you have multiple people coming in, then it will behave as if it was done sequentially rather than at the same time. And so being able to do that is important. And durability, the survival of crashes and failures, things of that nature. So you can look that up. But that is the main reasons that people give to use a database. So before we complete our overview of databases, let's look at the two major database types that you will be running into, commonly referred to as SQL and NoSQL. Now, SQL stands for Structured Query Language, I think. I just use the acronym all the time, but the basic idea is that it's a relational database. In other words, you have tables with relationships from one of the classes or tables or entities to another. NoSQL actually means not only SQL, and it's a little bit different. So let's just run through what these are about. Now, in an SQL database, it is relational. That means that you define tables, and these tables will have relationships with one another. Think of an example such as a consumer, a person who comes into a store who's going to buy an object. The object is located in a store. There's a salesperson. They work at a store in a particular location. The product itself has an identifier in it. There's a warehouse. All of these things have relationships with one another. So it's set up early in terms of being predefined, and it has all of these relationships. Now, in our example, we're going to be pretty much relationship free. At the beginning, we'll just be using tables, but that's the general idea of SQL. Compare that to NoSQL, or not only SQL. In that situation, it's not meant to have these statically predefined relationships between all of the entities, but it's more dynamic. It's more kind of free-flowing in what you do. And so that's the general idea there. As I mentioned, with SQL, it's very structured. That means that you will define these tables. You'll define all the fields within the tables. And it's very, it's very predefined, everything that you do. And of course, NoSQL databases are not like that. You will have a predefined schema. That is, imagine a picture. In fact, let me go to something like this. We're not going to look through this. This is an example of all the relationships in an SQL database. You have this schema. You have relationships between employees, jobs, dependents, departments, where they work, locations, countries, regions, etc., etc., etc. Those are all going to be predefined. And those things that we were looking at, there will be tables. All of those are defined a priori, meaning before you use them. And every column within them, in fact, when we look here, and we see each one of these things, these are going to be columns in the database, and those are all predefined. And then you'll be adding rows. So like if you think about this, there's going to be a row for one employee number one, and then there's a row for the second employee and a row for the third employee. That's in general how it works, okay? Now the way that it works in a NoSQL database, as I mentioned, there's not this set of relationships that you have going on. It's not set up to be structured before you use it. It is way more flexible in the way that you do things, and that's why, as opposed to having a predefined schema, things are flexible. Instead of having predefined tables, you have these things that are called collections. So the equivalent thing to a table in an SQL database is called a collection in NoSQL. You can think of it in Python terminology. This is like a dictionary, right? A dictionary is a collection of items, and a table in our database that we do with SQL is going to be defined by a class that is basically like a dictionary. It has fields in it, which are kind of equivalent to the different items in a dictionary, and in the same way we have collections here in SQL database. You define these columns, which are predefined, so you cannot vary from this. As opposed to that, the data that is stored within a NoSQL document tends to be in the form of JSON fields. So you have key value pairs in these JSON fields that are inside these collections. And every item that you add to a table is called a row in SQL. Every item that you add to a collection is going to be called a document. That document will be filled with these JSON fields. So that is the kind of the high-level comparison. We are going to we're going to use SQLite as our SQL database. In Quokka, I use Postgres and also SQLite. It's interchangeable pretty much, but for our simpler example, we'll use SQLite. I have created code that uses MongoDB, which is a NoSQL type of database, and so we will be looking at that as well as we go through databases. Now, we're not going to do super deep dive into any of these things, but we do want to give you enough of a background so that you are a little bit conversant in the types of database and how to use them within Python. Okay, so really quickly, for those of you that are less familiar with what Quokka is and does, this is Quokka. This is the data that's being stored in the database. We have information about devices. We have information about hosts that have been discovered. We have information about services that exist out in the network and that we are monitoring by getting their response time and availability. For these services, we're keeping time series data, not only for services, but for devices as well as for hosts also. So we're keeping all of this data in the database, time series data, which, as you know, grows over time. Certain things such as packet capture are kept in the database as well. And so information like this about packets that have been received and what's in them, etc., all are stored in the database, and we're retrieving that. So that is what Quokka is doing. That's some of it, just a really super quick glance at it. And now let's take a look at the code that makes this happen at a very high level. So let's just take a quick moment to look at the Quokka code that allowed us to get all of that cool data. Now remember, this is a super high level view. We're not looking at the code specifically for anything at this point in time. We just want to see in general how hard or how easy was it in order to do that. Now in Quokka, what we have is the application is separated into controller and model and views. The views are the user interface REST type stuff. If you've seen me talk about this, then you understand that. The controller is the logic where all of the threads are running to do the polling of devices and hosts, etc. And the models are where we define the actual data. So if I was to open this up, everything you see here that starts with a capital letter is going to be one of the tables, one of the SQL tables that we define. Now, the interesting stuff that I just want to show you from a high level, well, let me point out, so you have host and you have device, and you have service, and you have port scan for holding port scan data. For host summary data, you have host status summary. For host status data, you have the host status table. So those are all the tables that we've defined. I'm not going to go into those right now, but it's interesting from a high level view is these APIs. So we have a few of these that we can look at. I'm going to be looking first at the host model APIs because it's pretty straightforward. Now, we're using the database, and some of these, I don't want you to look at any of the details, but I just want you to get a general idea reading it kind of as a human from a high level. So here I'm querying the host table, and I'm filtering by my search criteria, which is the host ID. So that's pretty straightforward. Get all hosts, that's pretty boring. Set hosts, we'll look at this a little bit later, but it too is pretty straightforward. Record host status, yeah, that's where we record this stuff. Record host hourly summaries, that's where we record that. Get host status data. This begins to look a little bit more interesting. So here I have something that I'm going to return, which is going to be based on this query. So I'm going to query the host status table, and I'm going to filter by the host ID. Okay, we've looked at that before, but we're going to order it by the timestamp because we only want to get the most recent data for our graph. You know, that graph that shows the status of availability and response time. We're only going to want to get the most recent one. So we're ordering it by in descending order the timestamp that we have. And guess what? We don't want to get everything back. So we have a number of data points, which is typically, I can't remember if it's 24 or 30 or something like that. And we're returning that. The point is, don't worry about the details, but all I have to do is create a query like this, and bam, it goes out to the database and almost instantly returns the data that I'm asking for. It gets a little bit better. Here we have the summary data. Once again, I'm doing this type stuff here. Get host status data for the hour. So here I'm filtering it by not only the host ID, but I'm looking at the timestamp, and I'm saying timestamp, I want to make sure it starts with this particular hour, and that's how I get data for one particular hour. So let's look over here at the worker data APIs, and here you can see that I'm recording the capture. That's where I store it. We're going to go past that. It gets a little bit more interesting when we go and get the capture. This is the user interface asking for a particular capture. So if the request is for an IP address but is not specifying the protocol, then we're going to filter based on either the IP source or the IP destination. And it's able to do this OR function. And again, to give us this data really quickly. And once again, it's going to be descending timestamp order is what it gives it to us, and also limit the number of packets. Now here you can see I'm doing a filter of the IP address, but I'm also looking for the protocol. So I've got to make sure that the protocol is what I'm looking for. And here, not only am I looking for the IP address, but I'm also looking for the protocol, and I'm also looking for the source or destination port. So you can see, and of course, ordering by and limiting. So all I really wanted to do here is show you, you know, it's really pretty straightforward once you have a general idea of what you're going to do to make these queries. And the nice thing is, I didn't have to write any special code that traverses data structures, that reads files, etc. I can use this query language, which for me in Python is, in this situation, Sql Alchemy, and I'm able to get this data in a pretty straightforward manner. And as I mentioned before in those pictures, it is going to be scalable, it's going to be fast, it's going to be reliable, it's going to be that ACID stuff so that it handles concurrency, it handles failures, etc. And I can do all of this really cool filtering and ordering stuff using simple functions that I provide in the query. So that's a very high level view of how Quokka does it. Okay, so with respect to the code that we're using for this class, I want to do an overview first of all so you understand what it is that we will be talking about. Now it's Module 7, so you can see I have Module 7 Sql Alchemy, Module 7 Flask Sql Quokka, M07 C, Flask Mongo quokka, and M07D common. So the first one here is where I'm going to, in a standalone manner, I'm going to talk to you about just simply creating your SQL database. We're going to be using SQL Alchemy. We're going to be using it in a Flask context. So we're going to use Flask Sql Alchemy. I found it to be much easier to use this than to use the basic SQL Alchemy. Flask does a lot for us. So we're going to look at creating our SQL Alchemy thing, defining a table, and then we're going to look at reading in data, putting it into the table, etc., all in a standalone manner. That's what we're going to do there. Then the next thing that we're going to do is we're going to actually take that SQL knowledge that we've gained through doing this, and we are going to re-implement our mini quokka using SQL. So that's this thing right here. We're going to replace the internal data with the SQL database. And guess what? Here's something really, really important that I want you to understand. This thing here, this service display, host display, device monitor, host monitor, service monitor, did not need to change at all in order to do that. Why is that? Because we're using the REST API. And the REST API is abstracting all of the details of how we do the implementation. So all these applications care about is using the REST API to get and to put data in, and how the quokka server actually stores the data doesn't matter, whether it's using internal global dictionaries or whether it's using a database. And furthermore, it doesn't matter if we're using an SQL database or a Mongo database. So that is what we are going to be seeing. So we will need to be doing some stuff in order to make this whole thing happen. So we will be going through that. That will take a little bit of time, and then we're going to do the same thing with Mongo. Now Mongo, turns out it's going to be easier, but there's two things. So I don't want this to mislead you, because you look here at, well, look at all the SQL stuff, but look at the Mongo stuff. Basically, this is representing an evolution. What I've done is I've taken all of that display and monitor stuff, and I've put it into this common package. So all of that common stuff now lives here, and we don't have to worry about that. All we have to worry about in order to implement our Mongo, rather than doing the SQL version, is what I define right here. Now there is some difference, and we'll see what that is when we get to it, but that's what we're going to be doing. So let's get started with this standalone thing, this Flask Sql Alchemy simple. Okay, so here's the little application where I described to you how we use SQL Alchemy. Now it's a pretty short little module here. It's only 70 lines of code. You can see we import Flask, then we're going to import SQL Alchemy from the Flask SQL Alchemy module. The next thing we do is we create our Flask application. That's no different than what we've done in the other Flask stuff. Now this is all SQL Alchemy related. This is very important. We need to tell our app, we're going to set the configuration of SQL Alchemy database URI item. We're going to set it to SQLite. And now let me pause for a second here. If in quokka, I'm actually using Postgres. So this says Postgres because I'm using SQLite. I'm going to say SQLite, and Flask is going to understand that. Now the next thing that I'm going to do is I'm going to tell it where it is located, and this is the actual file that it's located at. If I was to go onto my system and look, this file, if it doesn't exist, it will exist after I run this code, and this is where my database is going to be stored, just in a regular old file. Don't worry about this one. This is just to suppress some notifications that get blurted out that are annoying, so just don't worry about that. And here's the important thing. This is where I declare my database. So I'm going to say my database is equal to, remember this is going to be a class, so I'm going to create an SQL Alchemy object. Oh, and there's one other thing that I'm passing in. What's this app thing? That's actually the Flask application. So I'm creating a Flask SQL Alchemy object, and I'm passing in the actual application that is my Flask application. Now I've actually seen examples of this where they're not even using any Flask, like any Flasky stuff, for example, REST APIs. In fact, in this particular module, I'm not doing any Flask things, so no problem with that. I'm just utilizing the fact that Flask has very kindly created this Flask SQL Alchemy module, and in it, the SQL Alchemy that I'm going to be using is way simpler than if I had to go through all of this other stuff that we were looking at here. So that is what we're doing here. We're creating our SQL Alchemy database object, and we are passing in the application. Now, let's look at this next thing right here. This is for those of you that didn't fall asleep during the object-oriented lesson, then you know that this is my definition of a class from which we can create objects, and so we'll be looking at that, but it's capitalized. You know, it's a class, just a convention, not a requirement. And this thing in parentheses, what's this thing in parentheses? If you recall, that is how we inherit from a superclass, and the superclass that I'm inheriting from is this nice model class that's been helpfully created by the folk person who did SQL Alchemy. So there's a class called model that I'm inheriting from. There is a boatload of stuff that's going to be associated with device that I did not create. It is all going to be SQL Alchemy related because of all the stuff that they've done for us. So all I need to do is inherit from this. Now the next thing is to look at this. Now if you were to just look at this and not think about it, you'd say, oh, you're defining kind of statically the fields that are going to be part of this table, or you know, the items, the keys. If you're thinking in terms of dictionaries, these are the keys, and this is what the value is going to be. Better idea would be to think of this as a table and these as the column names for the table. And so we're basically statically defining all of the different fields that are going to be part of this SQL Alchemy table that, for the purposes of what we're doing here, is going to be called device, and it is a class. It's a Python class. Now, if we were to look back here, remember, if I go back to this picture, remember about SQL databases, it's predefined schema, it is predefined tables, and it's predefined columns. Well, guess what? We are predefining the schema and the tables and the columns right here. So this is how it's statically defined. You're defining this, and this will become a table in the database. And you can probably read this as a human pretty easily. Guess what name is? And you probably didn't need me to tell you this is going to represent a column. Each of these is a column. Now, what is the type of data? All of these happen to be text. Now, you can have Boolean, you can have numeric data, you can have date type data, you can have different types of data. We're just going to use text to keep it easy. Now, database tables like to have a primary key, so we're going to say that the name is the primary key. That means that no two names can be the same, so you have to remember that. If you have used quokka, and if you've modified quokka at all by adding your own devices, and you made this mistake of not changing the name, this happened to David Bombal when he was first experimenting with quokka, you need to make sure that they are all unique because the primary key is true. Obviously, nullable is false because it's the primary key. Yeah, so I have, for my device, it's a simple version. It has the name, has the host name. That's what we would use to connect to it via SSH, let's say. It has an IP address and a vendor and an OS. That's all that we're doing. Now, the last thing is this, and I can't recall if I mentioned this before, but you may have seen these before, this REPR. That stands for representation or something like that. Basically, if somebody tries to do a print on a device object, this is what will happen. You'll end up seeing something that says device. This is my F string, remember, and these curly braces, this is the variable name that it's going to print out. What's it going to print out? Self.name. So when somebody takes a device object and tries to print it, and we'll do that in this code, then this is what's going to happen. It's going to call this, and we'll see in the output there's a time when I actually invoke this. And so this is what this special function is called. It's actually a method called repr, and it just prints out the name. We could put anything we want here. We could put everything in here. We could put name, host name, IP address, vendor, etc. But just for simplicity, I'm just putting this one thing. All right, so let's continue. Okay, let's continue and see what's going on in this file. Now we've defined the class, so we have the class. The next thing we're going to do is we're going to do a create all. Now this is a little bit misleading. Create all basically means if the tables, etc. don't exist, I want you to create them. If they do exist, I just want you to create the connectivity to them so that I can do stuff with it. So it really, create all seems like it's saying create all the tables. It's not really saying that. It's saying create all my linkages to the tables. And by the way, if the tables don't exist, please create them along with all of the appropriate fields, which all of the appropriate columns, which are going to be these fields that you see right here. So it's going to go out and do that. That's the first thing. The next thing I'm going to do, because I've run this a number of times and had multiple failures and goofed up with it, I always tend to go through here, and I am deleting this table. This is just a little standalone application. When we are running something like Quokka, we probably won't be deleting all the old data, but what we're doing in this situation, I'm going to do that. How do I do that? How do I delete the data from my device table? Well, this is the way that it's structured in SQL Alchemy. This DB thing is kind of magical. It's my object, and for every time I want to do something, I'm going to get a session. This is a Flask Sql Alchemy thing. It allows my code to become thread safe when I'm doing all of my REST requests, etc. So don't worry about this. You just will see it. In fact, you can see it highlighted here, session, 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 etc. I'm using it all over the place. That's just how you do it. Now on my little session that it is creating for me to do stuff, I'm going to make a query. Basically, a query is just a request that is made of the database to get something. And what is it going to get? It's going to get me this table. And so it's, what is the table? Well, all I need to do is reference my class name. Because of all the magical stuff done by SQL Alchemy and Flask Sql Alchemy, it is going to actually give me this table and all of the data in the table. And what I can do then is I can just say delete. Now, this is what we call method chaining or function chaining. I'm taking the DB, going down into that, getting the session, going down into my session, doing a query, and taking the output of that query and doing a delete. So that is, it kind of reads left to right. So don't worry too much about all the details. We've kind of gone over this in our Python description before, but that is what is going on here. So now we've deleted that table. What happens next? What happens next is something that you've seen me do before many times in many different circumstances. I'm just going out to my devices.yaml file, and you can see if we look over here, I do have my devices.yaml file, and it's going to actually read it in, and it's going to store it in devices. Now, before you go too much further here, I want to point something out. Do you see my devices.yaml file? For those of you that are used to the devices.yaml, I've used in other circumstances where we have lots of other information associated with it. And let me just go back here. I can't remember where I had it in 52 Weeks of Python, but I do have the same thing here. If you look here, you can see I have a lot more information defined because I'm doing a lot more in Quokka. So don't worry about that. It is important over here that I make it nice and simple because I need to not have fields. All of these fields are going to have to match up with the fields I've defined right here. Remember, this is kind of how we do things in our SQL world, is everything kind of has to match. I can't create fields out of nothing. It has to match what's here. And if I had a field here that didn't exist in this definition, it would throw an error. So that's what I'm doing. I'm loading in YAML devices. I'm doing a safe load, and I have my devices. It's going to be a list of dictionaries, all right? It's a list of dictionaries at this point in time. Devices is a list, and every single item is a dictionary, and that dictionary is going to basically be the Python representation of this. It will have a key of IP address and a value of 10.1.254, etc. Sorry if I'm boring you, but I want to make sure everybody understands that, because you may look at this and say, whoa, hang on a second, what is going on? So let's pause and look at this. DB, we've seen that before. Session, we've seen that before. .add, okay, that makes sense. Up here we had .delete. Here we're doing a .add. So we're going to add something to the database. Now, what are we going to add to the database? Look at this and pause with me, because I don't think I even gave thought about this until I started to teach it myself. I just used this pattern and I assumed what it was doing, but I didn't actually think about this. If you saw this by itself, what would this be doing? It would be creating an object of type device, right? Are you with me? You have class device. That's my class definition. Hopefully you weren't sleeping too much during the object-oriented stuff. This is my class. When I say down here, device parentheses something, then I'm creating an instance of that object, an instance of the class that's going to be my object. And what am I passing in? Well, we understand device. Device is my dictionary, okay? So that's good. And if you were to just look at this and not worry about understanding it, you would probably say, okay, we're going to create a device object, which is what is defined up here. And we are going to pass in as data this device that I just read in, and the name, host name, IP address, vendor, OS will be appropriate to what this particular value is. That makes sense. But let me take a minute and explain this to you. When you see this type of code where you have something that is a dictionary and you have a star in front of it, this is a special Python syntax that's going to do something special. And I'm going to explain this to you, and we're not going to spend a ton of time on this, but put this into your mind. Keyword arguments, or KWARGS. If you want to write that down and Google Python KWARGS, you can get more of a definition. What this is going to do is it's going to take this thing called device, which is a dictionary, and it's going to change it into parameters that actually are built from this device piece of this device dictionary, and it's going to have keyword value, keyword value, keyword value. It's like calling into a function and passing in keyword arguments. So this is going to have, let's remind ourselves, it's going to have name equals whatever the name is, comma, host name equals whatever the host name is, IP address, comma, etc. That's what this is doing, all right? Feel free to ping me if you have further questions on this. You can look up KWARGS. That is typically how this is referred to when they specify what needs to be passed in here. And it allows you to pass in anything that you want. So you can have, you could have 5 of these, you could have 100 of them. Now that wouldn't work for our SQL Alchemy, but you get the idea. That's how you pass in a variable number of keyword arguments, and that is by doing * dictionary name. Okay, so let's think about this. Let's get back to SQL Alchemy. What are we doing? We're adding a row to the table. We're adding a device. So we started with an empty device, right? Sorry, an empty device table. So it's empty. Now we're adding a row, and we're going to go through this for every device that we have, and we are going to add devices to that table. All right, hopefully that's pretty clear. We'll pause after a second because we're not done yet. What we need to do, similar to what you may be familiar with if you're a network engineer, it's not really happening until you do a commit. So when you do a commit, this is when the data gets committed to the database. And remember, in this picture that I was showing you, we talked about how, not this picture. We talked about why to use a database. We talked about reliability. We talked about ACID and the atomicity and durability, etc. This is what you get with the database. It won't get partway through doing this and then your database is screwed up. It will either complete it or it will go back to the way that it was. So that is what your commit does for you. Okay, so now we're ready to get started. We have data in the table. Let's look at how we can access it and do stuff with it. Okay, now that we have the general idea, we can go a little bit faster. This is taking longer than I had anticipated, a little bit longer anyway, and so I want to make sure that I get through this. So if you feel like you have to pause in the middle or whatever, you're probably doing that anyway, feel free to do so. So we've created our database. We have data in the table. Now let's look at the code to actually get stuff. So device, that's my table. Query, so I'm going to do a query from that table. So this is an alternative way to do things. Sometimes we do db.session.something. You can also use this pattern of referring to the table by name. So I'm going to say device.query.all. What do you suppose that does? That gives us all devices. I'm going to go now and print them all out. So here's all devices. That's going to be a list. And then I'm going to print out device. Now let's pause for a second and think, what is device going to be? And if your answer is it'll be a dictionary with all the device data in it, you would be incorrect. It's going to be an object, and that object will have extra data in it. But in order to get it into a form that is more Python friendly, we can use this built-in function. This vars function basically is going to take an object and it's going to change it into dictionary format. And if it's a dictionary, then our pretty print that we use periodically is going to be able to handle this. And why don't I pause here just to show you this executing. So here's my actual code running, and let's go up to the top. Here is my all devices, and this is what that pretty print prints out. When I did vars, it changed what I had, which was an object, into a dictionary with keys. You can see here's some internal data that it's printing out, and there's another object, the instant state, blah, 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 blah. Here's some things that we're familiar with: host name, IP address, name, OS, and vendor. And there's two of them, and that matches the devices.yaml. We have two of those. So that is our list of all devices. All right, that's how we got that. So that was getting all devices. I'm using this device.query.all format for getting at the data because it's a little bit simpler. Now here I'm doing something a little bit different. I'm not getting all of them this time. This time I'm doing device.query, but instead of saying all, I'm saying filter by. Now what do I have to pass in if I'm going to filter by? Well, I can pass in a field name. If I pass in an illegal field name, it will throw an exception, but I need to throw in a legitimate field name, and then it will find this particular thing, or it will attempt to get it. So I'm filtering the data. So obviously with two devices, that's not a big deal. If you have 1,000 devices and you're trying to get one device, then you'll be happy to know that database code over the years has evolved so that it's very quick at doing stuff like this. And just as an aside, you can index your database tables so that they go even quicker. But it's going to get this, and then I'm going to say, okay, of those results, I want you to give me the first one. And then I'm going to print it out. And here you see device with filter by host name. This name right here, it's got just one. It's matching this one right here, SBX NXOS management cisco.com. So that is how we would use filter by, and I think I've shown you some other more elaborate ones that I use in Quokka. Now let's go in and actually update data. And so how do you update data if you have a device? Well, what I'm going to do is I'm going to take that device that I just got. So I have this thing called device. It's an object. And I'm going to say, okay, it's an object, so I'm going to refer to a field. And that is my .vendor field. and I'm going to set it to a value. That's pretty simple. All I need to do is do that. And now all I have to do is commit. So this is actually simpler than you would expect. I would expect that I would have to do some type of update or something like that. But because this device object, where did it come from? It came from right here. Because that device object has all of this wonderful SQL Alchemy stuff in it, in addition to these fields, then it knows when I do a commit that I have changed that item, and it will go and update the database appropriately. And what we end up doing now is I'm going to do a query for everything, and we're going to come back and say, after I've done device updated with a new vendor, I'm going to say all devices after name change. What did I change? I changed my Cisco device to not Juniper up here. Let's see, which one was it? It was this one right here, SBX. Actually, no, it was that was my filter by. That is the one that I changed. When I look at what it was before, it was Cisco. That's the one that I got. And now when I look at that one, the actual vendor's name is not Juniper, which is just kind of silly, but that's what I did. So that is that. Now here I'm saying filter by name equals no name will match this, and I should find none, and the end result, the thing that I got back, device is actually equal to none in that situation. So that worked as expected. Now let me show you a little bit more. Instead of filtering, and of course I could have done filtering and ordering, I did that in the stuff I showed you from Quokka. In our situation, we only have a couple devices, so if I filtered, then order by, there would only be one of these. So now I'm going to say, okay, get me all of the devices. You can see I'm getting all of them, but I want you to order them by device IP address. So let's look here. My device IP address, you can see the first one is .68 and the second one is .67. I'm getting all the devices, and now I'm going to go through all the devices and I'm going to print them out, but they should be in the appropriate order. Yeah, sorry, this is what I'm actually getting. I actually confused myself there and I had to pause. Hopefully I remembered to edit it out, but I actually added some stuff. So I printed out information for blah, 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 blah. Do you see this over here? I thought that would be cute, and actually all it did was confuse me when I looked at the output. But remember, what we're looking at is that one went 68 to 67, but we did order by. And so what have we got? This time we've got 67 and then 68. So it's done the sorting for us just by us doing this order by. And you can do that on any of the fields that you want to. You can do it on multiple fields. It's very impressive. If they're indexed, it will be super fast. If it's not indexed, it's still reasonably fast. Now, the next thing that we're going to do is we are going to actually do a delete. What we're going to do this thing, let's start from the inside. I'm going to get a device with the IP address of .68, and I'm going to get the first one. That returns to me a device. And what is it going to do? We're going to do a delete for that device. And then the next one, it's going to do a delete of one with the operating system. I just chose things at random here, but wanted them to be one from one device and one from the other device. And then I do a commit, and at the end, I do a query all, and I print out all of them, and it is an empty list. Hopefully that wasn't too fast, and it made kind of sense. We're going to do a little bit more of this when we start to look at the next thing that we'll be looking at. But yeah, hopefully that gives you an idea of the things that you can do within your simple SQL Alchemy. When we get here to Flask Sql Quokka, we will be actually replacing that data with classes that we define and with accessing that data from the Quokka server. So yeah, let me know if you have questions. If I went too fast, I'm happy to answer any that you might have. All right, let's wrap this thing up by talking about what we discussed and reviewing it a little bit. Remember, we talked about how we're going to be moving data out of the Flask quokka server, kind of a mini quokka that we implemented before, and moving it into a database. So we want to be able to store stuff in the database where we ought to do. Why do we store it in a database? Well, all of these things are reasons: scalability, performance, reliability, concurrency. You can do filtering and ordering. They're very fast at doing that. And this thing, ACID, which is a little bit sums up some of the things that we mentioned here, but it is a key acronym, and you might want to know what that means. We then talked a little bit about different types of databases. So you have SQL databases, which are very much structured, predefined in terms of the schema and the tables and the columns. So everything is preset in your database in terms of its structure, and it is relational. So you have relationships between things, even though we're not using them that much. And then there's NoSQL, which stands for not only SQL, and really these are way more flexible. That would be the main thing. Instead of having predefined stuff, you have JSON fields instead of columns, so you can have fields that are extra or less than what normally you would have. The rows are called documents, the tables are called collections, etc., but it's way less structured. And so we'll be looking at both of those when we get into the coding part of this. Now, we did look a little bit at all the cool data that's stored in Quokka. So the stuff like this is in simple tables. When we drill down into one of these, you can see that this data here, this time series data, and the summarized data is all kept in time series database tables, and it requires some intelligent filtering and ordering in order to get that data. And so we looked at that a little bit. Then we looked at the actual code that I wrote for this particular session. This is Flask Sql Alchemy Simple, and we talked about how we're using Flask Sql Alchemy because it does make things a lot simpler. All you need to do is create your database using SQL Alchemy class and passing in the object. Then you can define your tables. You do it something like this, where you inherit from db.model. Hopefully you were awake during the time when I talked about object-oriented stuff, so you understand a little bit about what's going on there. You're defining, as you can tell, your columns. It's very structured in what we do. We talked about how you will create them, how you can do queries. We read in devices from a YAML file, and then we add them to the database. We talked about this thing right here, which is not related to databases, but it is a Python thing. These are KW args, which translates this format here with the 2 stars, will translate from your dictionary into keyword arguments that get passed as parameters to this call. So listen if you want to find out what happens. We talked about how you do things like commits to make everything actually take place in the database. We talked about doing queries, like getting all of the things that you can filter by particular items, so you can look for a particular item and get that one, and then we printed that out. We talked about how you can update by just modifying your device object that you've retrieved from the database. That's that thing right there. You modify it, and then you just do a commit, and it saves it for you. We looked at filter by, we looked at order by, and then we deleted everything. So that's what we did in this session. Hopefully that makes at least a little bit of sense to you and you have a better understanding. We'll be moving on to actually using what we learned to do that thing that I was showing you before, which is changing the data that we're storing the devices and hosts and services in our mini quokka application, and storing those instead of in memory, storing those into a database. But that's for next time. Hopefully this made sense. As always, if not, shoot me a question or something, and thanks for listening.